key word for what we need to do is right here at the beginning. It's prove. We need to prove this identity. If we're proving an identity, the first thing we need to do is draw a line so we're not working on one side to the other. And then we look, and this one's different. First of all, some of our strategies that we've had for proofs is like change everything to sine and cos. You're like, it's already all sine. Get it to a single fraction. You're like, well, they're both over 1. It's already a single fraction. Your denominators are the same. You can't build the other side. What do we do? How do we prove that sine of pi minus x is equal to sine of x as a proof? Now, we had a similar question to this one on our quiz from last unit, where you had to say one thing was equal to another, and you looked at it graphically.
Yeah.
Okay? So you could look at this graphically again to say that these are equal, but what we're going to do is we're going to do an algebraic proof. We're going to prove this one. And the way that we're going to do that is we're going to say, hey, I have sine of something minus something. That is, and that should trigger one of these new formulas. Because on the left-hand side of those new formulas, we have alpha minus beta, alpha plus beta, alpha minus beta, alpha plus beta. So noticing that, I might just go alpha above the first one, beta above the second one. So if alpha is pi and beta is x, I can change the left-hand side to the formula that says sine alpha cos beta minus cos alpha sine beta. Cheat a little bit. And often with your sum and difference identities in a proof, you feel like initially you've done something wrong. Because I went from something that was simple to something that's bigger and complicated. But now that it's bigger and complicated, look at some of these values. Sine of pi, that's on your unit circle. What is sine of pi? And same thing with cos of pi, that's on your unit circle. Man, I have to cheat again. So nice to be able to do this. Still matches up perfectly with our equal sign. Sine of pi, think y coordinate at pi. It's 0. What's cos of pi? Close? -1. Okay. Ooh, 0 times table.
0.
Oh, good. So this is going to be 0. And here we have a negative, negative. It's going to be plus, so it's equal to sine. And we're done. There is the algebraic proof of why sine of pi minus x is equal to sine of x. The graphical proof for this one might be difficult, but I'll show you just because I want to review some things about graphing. Okay? I'm going to graph the right-hand side in green, and the left-hand side I'll graph in blue. So when we're graphing these, the green one, which is just sine of x, we'd have our period of 2 pi. Sine starts, has an amplitude of 1. Sine starts in the middle, going up, so you go. This is just my basic sine graph. Actually, I'm going to graph the, just because I made my axis in blue, I'm going to graph this one in purple. Now, graphing sine of pi minus x, normally we don't have the shift before the x. So are you okay if I rewrite this as negative x plus pi? Is that, can you see that that's the same as pi minus x? What's the plus pi going to do? Shift it pi to the left. Why does it go pi to the right in this case? because it's not factored. So this is one of the things where graphically this one is difficult because it's not in factored form with that negative. So you'd have to take an extra step, factor out the negative, right? And that's the thing we always forget, especially when it's just a negative. So what will this do to my sine graph? The negative is going to flip it over which axis? You're going to change your x values, you're going to flip it over the y-axis. Can you see that if you flipped it over the y-axis, it would look like that? That would be a flip over the y-axis. And then we would need to take each of these points and shift them pi to the right, and your graph would be identical. So the graphical proof of this one is a little bit more difficult. But we're going to find, now that we know this identity, an algebraic proof is going to be easier to show that they're the same than a graphical proof. So earlier in the unit, we just had graphical ways of doing this. Now we've learned our sum and difference identities. We can prove things with that new formula. Okay, so questions for this one are 9, 10 II, 11, and 14.